statistics. So, again, to revisit your variables, there's two kinds of variables. There's a discrete variable and there's a continuous variable. Now, we talked about this way back like in chapter 2, maybe chapter 1, maybe. And we said anything with discrete is countable. Whole numbers. They're called your counting numbers. So I can count 1, 2, 3, 20, 800, 900. They're always going to be countable. How many books on your desk? How many cars are on the road? How many stop signs did I pass? They're countable. They're discrete numbers. Your continuous has all the little fractions. You can use fractions in between. How much do you weigh? Do you weigh really 96 pounds or do you weigh 96.2 pounds? How tall are you? Are you really exactly 4 foot 2 inches or are you 4 foot 2.1 inch or 2 1/4 inches? Continuous gives us the decimal, the fraction. How much milk did you drink at lunch today? You certainly maybe just didn't finish 8 ounces exactly. Maybe you drank 7 1/4 ounces, as opposed to being discrete, saying 7, 8, 9. In our binomials, we're going to work with discrete values, countable values, such as how many days did it rain? I'm not going to count a partial day of rain. I'm going to count how many, that's going to count as a day of rain. So we're going to look at discrete values in this. And we visited these before. It was probably chapter 1. The review decide whether these variables are discrete or continuous. So let X represent the number of Fortune 500 companies that lost money in the previous years. What is it I'm counting? Fortune 500 companies. So counting companies, one company, two companies, is that a discrete measurement or continuous? Discrete. I can't have a partial company. I can't say 2.5 companies lost money. I could say 3 companies, 4 of those companies, 5 companies. Countable. You want to look at what is it that you're measuring. Let X represent the volume of gasoline in a 21-gallon tank. A volume formula is usually your 3 dimensions. If it's a cylinder tank, I have a volume for a cylinder. Does it have to come out to a whole number every time? Nope, that's your continuous. So while this guy is a discrete way to count, this guy is continuous. Okay? So again, we're just visiting those that we visited, probably chapter 1. So let X represent the speed of a rocket. Is the speed discrete or continuous? Continuous. So give me an example. 200.5 miles per hour. Absolutely. 200 would make it discrete. 200.5, I can have a continuous amount. Okay, so this guy is continuous. Always ask yourself, can you make a decimal point? Can you use 1/2? Can I use 1/2? That's going to help you decide. So yeah, I could go 56.5 miles per hour. Okay? Let X represent the number of calves born on a farm in 1 year. Discrete. I can't have a partial calf born. I can have 1, 2, 3, 4, 5, 100. But I can't have 100.2 calves born. Okay? So these are things that we're looking at. Now, when we make your probabilities, these are really, really important. There are 2 factors that have to be present for you to have a discrete probability distribution. Remember, discrete says countable numbers. These are countable. The first thing I have to do is make sure that my probabilities are true probabilities. My probabilities fall between 0 and 1. My probabilities cannot be negative, cannot be greater than 1. So it falls between 0 and 1. 0 is my impossible case. 1 is my certain case. Okay. So two things. My probabilities have to be correct. They have to be valid probabilities. And the sum of all my probabilities for that one event has to add up to 1. Like such as flipping my coin. I flip a coin, 1/2 and 1/2. It has to add up to 1. There's no other possibilities. Okay, so this is really, really, really important to know if this is a probability distribution. So the first thing we're going to do, and we've done this before, is we're going to make your frequency distribution. We're going to use your table. We're going to say, okay, out of 5 days you're on vacation, we're going to calculate the rainy days. Now, can I go on vacation for 5 days and have it never rain? So I could have a 0. I could have it rain on the first day, the second day, the third day, the fourth day, the fifth day. So we're going to make our distributions look just like we did before. But instead of doing like just add frequency, we're going to do your relative frequency because this is your probability. We're eventually going to get your P of X on this. And we're going to check that all your probabilities in here fall between 0 and 1, and that the sum of all my probabilities add up to 1. Okay? It'll make sense once we start doing it. And these kind of do make sense because you've already done some of these frequency charts, and we put probabilities on them. Because you remember when we did your probability one? I said if you do your L1 as X and you do your L2 as a probability, you won't get a sample standard deviation because your probabilities add up to 1. So you can't do 1 minus 1 for a sample. So we have things like this. This comes right from your book so that you could see just an example of this. We'll just kind of hit this and we'll verify these and then just kind of just stop there. We'll take a look at your passive-aggressive traits for 150 people. They were rated from 1 to 5. So if they're rating themselves from 1 to 5, where 1 was extremely passive and 5 was extremely aggressive, you cannot put a score of 1.2 in there. You could give me a 1, a 2, a 3, a 4, or a 5. How come I don't have a 0 on my table? How come I didn't account for 0? Because it's 1 through 5. A 0 is not a possibility that they could return. You could tell me 1, you're extremely passive. 2, I'm kind of passive. 3, I really don't have either. 4, I'm a little bit aggressive. 5, I'm extremely aggressive. So a score of 3 indicates that you're really kind of middle of the road. So these are discrete variables because they're whole numbers, they're counting numbers, and I have no 0 because that wasn't part of the deal. So if you take a look at your book, they gathered this information, and here's your table for it. They gathered your information with your frequency. Now, we all know how to do relative frequency. Relative frequency is part over whole. All of these add up to 150 because we said we had 150 people that we asked. So 24 over 150. This is where they get their information from. Okay, all their information comes off of this. And they calculated it already for you. So all that we have to do is figure out our P of X. That's this guy. That's your relative frequency, basically. So when they divide this out, this is 0.16. This is 0.22. This is 0.28. 0.20, 0.14. They just put it into a different graph. That's all they did. They took this row right here and just put it down here. You would do your regular rounding rules. Did one of these not round?
No, I'm asking. Let's say you have like 3 decimals.
Right.
And it goes to 5.
They probably didn't get 3 decimals because it's 150. So they probably got only 2 decimals. They probably terminated. Yeah, it just terminated because it's based on 150. So if it wasn't, then we would do 3 decimals, right? Now, here's what your probability distribution says to you. Are all these probabilities between 0 and 1? True? They have to be. You made it happen. You took part over whole. The sum of all these probabilities have to be what? 1. So that's this probability, P of x, that they put in a separate table. All it is your relative frequency, part over whole. That's your probability, part over whole. So we all with this so far? Okay. All right. We're going to construct this probability table, and then we'll call it a day. I think I'm losing half of you.